Number 25 is quite Desmosable, so I will show you that approach first, but then I'll show you how to do it by hand, because as I always like to say, it's important to be flexible. It's important to know how to tackle these problems in various ways, just in case Desmos is not as viable on a problem. It just makes you a better problem solver. If you're going for that top score, you need to be a strong problem solver. You cannot just be rigid, okay, I do this, or I do this, or I see this problem and I do this. You got to build that flexibility. So that's why I like to show you these different approaches. But hey, look, at the end of the day, if I can get a Desmos answer to this question without doing much work, of course I'll take it. There's no style points on the SAT. Do what you got to do to get a right answer in the moment. But when you're practicing, it's good to understand all these different approaches. So we can just put this equation directly into Desmos. And usually if you click around, they give you these 2 points that are endpoints of the diameter that are vertically aligned here. So you want to use these 2 points for your diameter. So the numbers are a little ugly, so we have to find the distance between them, which basically just means subtracting the y coordinates. So let me just extract these here. So it's going to be 15.92285 minus negative 9.92285. Now this is my diameter, so let's actually just divide this through by 2. This is the radius, and so now we just need to test the choices, see which one matches 12.9 and change. So we'll do square root of 109, nope. Square root of 149, close, but not quite. Square root of 167, yes. So this one looks pretty good. 12.92285, 12.92285, cool. So it should just be choice C. Now, how can we do this one by hand? We're going to complete the square. Let's move the 6y over here. We'll leave the 109 on the other side because ultimately our goal is to get this into the standard form of a circle, which is this. So I want all my numbers over here, and then I want this x minus h squared blah blah on the left. So let's get the 6y over. So it's x squared plus 14x plus y squared minus 6y is equal to 109. Now, completing the square, we're going to start with the x's. We're going to take this b value next to the x. We're going to divide it by 2 and square it. So in this case, it's just going to be 14 divided by 2 squared. So 7 squared is 49. I'm going to take that result and add it to both sides. Now, technically, I don't really care about what's going on the left side at this point, but I will just do the whole thing. So if you wanted the center of the circle, you could get it. All we really care about is what's going on over here, but we'll just be thorough, right? Because we've got x squared plus 14x plus 49. And if I factor this, we get a nice clean x plus 7 squared. So we know now that the x coordinate of the center is negative 7 based on our equation above. We'll do the same thing now with the y's. So I'm going to take that negative 6 divided by 2 and square it. So we get negative 3. And, we get 9. Negative 3 squared is 9. So I'm going to add that to both sides. And again, all I really care about is the right, but we'll just continue finishing this off. So I get y squared minus 6y plus 9, or y minus 3 squared. And so I know the center of our circle is 7, or is negative 7, positive 3, right? Extracting the h and the k from our equation, following the model. And in fact, if I go back to our Desmos here, and I put in negative 7, 3, again, it's not something I can prove with just eyeballing it, but this does look like it's a pretty good center. Like it's aligned on that negative 7, and it does look like it's, reasonably halfway between those values. So yeah, cool. But again, all we really care about is what's going on over here, because this is all going to equal 167. Now this, remember, is our r squared. So if the radius squared is 167, the radius is just the square root of 167. And that is choice C.